What's going on, everybody? Got another video here for you. This is finite math. So if you've got to take that class, I'm going to have a lecture series on that class. So let's look at this. This is polynomial and rational inequalities. So let's go ahead and get started. So first it says use the graph of y equals x cubed minus 5x squared plus 2x plus 8 to solve each of the given inequalities. Alright, so we've got the graph here, and we want to know, when is this function over here greater than 0? Well, that's when the graph is above the x-axis. See, here's your x-axis and this is your y-axis. So whenever the graph is above the x-axis, that's when it's positive. So you can see the graph is above the x-axis right here and right here. So you can see from 1 to 2, so that's 1 to 2, or from what? Or from, see here, starting at 4, from 4 to infinity. All right. Now, it wants to know, when is this function less than 0? So that's when it's below the x-axis. And you can see it's below the x-axis here and here. So you can see it's coming down, but it's also going to the left. So you can see from negative infinity to 1. Nope, wait a minute. Yeah, no, never mind. That's right. And then you can see it's below the x-axis from 2 to 4. So those are your answers for that one. That's pretty easy. It's pretty easy when they give you the graph and ask you to find where it's positive or negative. You just look at the graph. Above the x-axis, it's positive. Below the x-axis, it's negative. All right. So now let's look at this, solving polynomial and rational inequalities. The first thing we're going to look at is polynomials, quadratic functions, stuff like that. So here's some steps for finding it. If the steps sound confusing, then don't worry about it too much. You can pause the video and write down the steps. But I think the way that I work them, it'll make more sense. You'll understand it better once we start working. So it says rewrite the inequality so that all terms are on the left side and 0 is on the right. So get everything on one side of the equal sign, set it equal to 0. Find the x-intercepts. So basically what you're doing there, once you get everything on one side of the equal sign, set equal to 0, you just take that function, set it equal to 0, and solve for x. All right. Divide the x-axis into regions using the solutions found in step 2. So we're going to make a number line and break it up into however many regions we need. That'll all make sense when we start working the problem. Test a point in each region by choosing a value for x and substituting it into the equation for y, and then determine which region satisfies the original inequality and graph the solutions. All right. So let's get to the good part. Let's get up here where we're going to solve these things. So we want to solve each inequality. I think we've got 3 of each, 3 of the polynomials and 3 of the rational functions. All right. So what we want to do is we want to change this to an equation. And so we've got x squared minus x minus 12 equals 0. So all I did here is I just subtracted 12 to both sides. That's all I did. And now what we want to do is we want to factor this thing. So I've got x minus 4, x plus 3 So x minus 4 equals 0, or x plus 3 equals 0. So x equal 4 or x equal negative 3. So there's our solutions to that equation. All right. So what we're going to do now is we're going to make a number line, and we're going to plot these points on the number line. So we've got negative 3 here, and we've got 4 here. And what this does is it breaks the number line up. In this case, it breaks it up into 3 regions, okay? You may have just 2 regions, you may have 4 regions, or whatever, okay? This problem, we've got 3 regions. Then what we want to do is we want to pick a test point from each region. Okay, so here I'm going to choose, let's choose, let's do this. Let's choose x equal negative 4, x equals 0, and x equal 5. So where did those numbers come from? Okay, I'm going to take a little bit longer to explain this first problem, okay, so you can understand it. So where did these numbers come from? Well, see, negative 4 is less than negative 3, 0 is between negative 3 and 4, and 5 is greater than 4. See, negative 4 falls to the left of negative 3, 0 falls in between, and 5 falls to the right of 4. If you wanted to, you could choose negative 1 million over here. You could choose 2 million over here. You could choose 1/2 in the middle here if you wanted to. But why would you do that? Just pick something easy. That's all you got to do. Okay? All right. Now, let's test out x equal negative 4. Okay? Test x equal negative 4. Now, what we want to do is we want to take this. Now, one thing we might want to do here is take this inequality, and let's rewrite this inequality as, I'm going to write it down here. I should have written it. Well, let's see if we can do this. Let's take this and just kind of move it down some. All right. So what we should have done here is x squared minus x minus 12 is less than 0. Just go ahead and get everything to one side of the inequality. Okay, I should have done that first. I didn't, but I should have. All right. Now, what we want to do is we want to take the negative 4, the 0, and the 5, and we need to plug it into here and see what we get. Now, let me make this easier on you. So, do you agree that this right here is the same as this? Those are the same thing. It's just this one isn't factored, this one is. That's the difference. Okay? That's the difference. So we can take the negative 4, the 0, and the 5, we can plug it into here, or we could plug it into this one. It doesn't matter. Okay? But let me say this. It's easier to plug it into here. Okay? And I'm going to show you why. So let's test this out. So let's do x equal negative 4. So when we plug the negative 4 into here, okay? So if we plug negative 4 in, negative 4 minus 4 is negative 8, right? That's I don't care that it's negative 8. All I care about is that it's negative, okay? So this is negative, okay? So when I plug the negative 4 into here, that's going to give me a negative 8, which is a negative number. And then if I plug the negative 4 into here, negative 4 plus 3 is negative 1, okay? So you can see this is going to be a negative times a negative. That's what I have right here. So a negative times a negative is equal to a positive. So that means any number I choose from this region, I'm going to get a positive answer. That's all I care about. I don't care about the exact number. All I care about is it positive or negative. Now, if you want to, you can come up here and say, okay, I'm plugging in the -4. -4 minus 4 is -8. -4 plus 3 is -1. And that equals +8, which is a positive number. Okay? You can do that. Or you can come in here and you can take the -4 and plug it into this one, which would be -4 squared minus -4 minus 12. And you can see that's going to be 16 plus 4 minus 12. That's 20 minus 12 is 8. You get the same thing. But let me ask you this. Which is easier? Is it easier to do the numbers and get an answer in this one or this one? Or do you think it's easier to say, well, okay, if I plug -4 minus 4, that's a negative number. -4 plus 3 is a negative number. A negative times a negative is a positive. That's easier to do. Okay? Now, it doesn't make that big of a difference on this problem because we're plugging in -4, we're plugging in 0, and we're plugging in 5. But on some of these, you're going to be plugging in fractions. And to avoid adding and subtracting the fractions and that kind of stuff, all you do is just plug them in, and then you just say, okay, well, is it positive or negative? Okay, that's all. This right here is all we really need to determine the positive. We don't need the exact number. I hope all that makes sense, and I didn't confuse anybody. All right, so now let's do the x equal 0. Let me see if I can erase this. All right, what was that? X minus 4. All right, so look at this. If I plug the 0 in, now this one would be easy. If we plug 0 in, we just get -12, right? It's a negative number. That's easy. 0 squared minus 0 minus 12 is -12. But let's do this. So I plug the 0 in. 0 minus 4 is -4. That's a negative number. And then 0 plus 3 is 3. That's a positive number. So you can see I've got, this would be negative, this would be positive. Negative times a positive is a negative. So this would be a negative solution in there. And then for the x equal 5, well, if I plug the 5 in here, 5 minus 4 is 1. That's positive. That's positive. And then 5 plus 3, that's a positive number. 5 plus 3 is 8, which is positive. And a positive times a positive is positive. And so that would make anything in here positive. Now, how do we determine what our solution is? Well, what are we wanting? Well, if you look at this equation right here, okay, what do I want to know? I want to know when x squared minus x minus 12, I want to know when is this less than 0. When is it negative? And you can see it's negative right here between -3 and 4. So our solution is -3 to 4. And we use the parentheses because it's not less than or equal to. Remember, parentheses means the -3 and the 4 are not included. And if you remember, brackets would mean that the -3 and 4 are included. But since it's just less than, that means we just use the parentheses. And so this would be your solution here. All right, let's look at the next one. All right, so let's go ahead. We've got r squared plus 3r minus 4 is greater than or equal to 0. Okay, so I went ahead and moved everything over. So let's change this to an equation and solve for x. So if I factor it, that's going to be r minus 4 plus 1. R minus 4 equals 0, or r plus 1 equals 0. So r equals 4, or r equals -1. And so what we want to do now is we want to plot these on the number line. And that's going to break this up into 3 regions again. So now what I need to do is I need to choose a number from each region. So how about r equals -2, r equals 0, and r equals 5. All right. And now we want to test each one. So we've got r equals -2. Now remember, we can take the -2, we can plug it into this one, or we can do what? We can come down here to where it's factored just because it's easier to do. That's why. Okay, because it's easier to do. Now, if you have a calculator, yeah, go ahead and plug that in with your calculator, but it's still, even with a calculator, it's still easier to do this one. Okay? All right, so let's plug the -2 in. -2 minus 4, that's a negative number, right? -2 plus 1 is a negative number. You see that? And a negative times a negative is a positive. So that's positive. See? -2 minus 4 is -6. -2 plus 1 is -1. That equals +6. But we don't care that it's +6. We just care that it's positive. All right. Now let's do r equals 0. So 0 minus 4 is -4. That's a negative number. 0 plus 1 is 1, which is a positive number. A negative times a positive is negative. So that's negative. All right, and then we're going to do the r equals 5. 5 minus 4 is 1, which is positive. 5 plus 1 is 6, which is positive. Positive times a positive is positive. So this would be positive. Now, what do we want to know? We want to know when is this, it's wrong one. When is this inequality, when is this greater than or equal to 0? So when is it positive? And you can see here, it's positive here, and it's positive here. So our solution is going to be -infinity to -1. Okay. Now, I'm going to actually need to go back and check how I wrote the answer on the first one. But one thing I've noticed that students miss a lot is when they're writing their solution, they'll write -infinity to -2. But remember, it's to the -1. I need to make sure that I didn't do that up here. Yeah. See, be careful and not write like -4 to 5. Okay. Make sure you don't do that. All right, so we've got -infinity to -1. Now remember, this is or equal to the inequality. So that means the -1 is included. So we're going to put a bracket there. But remember, infinity or -infinity, you're always going to put a parenthesis there. You can't include infinity. And then we're going to go from 4 to positive infinity. So that's 4 to positive infinity. And this is your answer. All right. All right, so let's look at this one. I think this is the last one on the polynomials. Yeah, and then we'll get into the rational. The rational ones are inequalities. That's the one students struggle with the most. All right, so you can see everything's already on one side of the equal sign, so we're good there. So now let's just take the x cubed minus 4x, set it equal to 0. And to solve this, we're going to need to factor out of x squared minus 4 equals 0. And so we get x times x minus 2 times x plus 2 equals 0. And so x equals 0, or x minus 2 equals 0, or x plus 2 equals 0. So x equal 2, or x equal -2. So we've got 0, 2, and -2. Those are the ones that we're going to have to plot on the number line. So let's draw our number line. We've got -2, 0, and 2. And so you can see in this problem, this breaks it up into 1, 2, 3, 4 regions. All right. So let's pick a number from each region. We'll do x equal -3, x equal -1, x equal 1, and x equal 3. Like I said, the ones you pick from each region, you can pick whatever numbers you want as long as they're in those regions. But pick something simple. Don't make it difficult on yourself. All right. So now let's do the x equal -3. So once again, we can plug it into this one, or which I think it's easier to plug into the ones that are factored. Okay. All right, so let's plug it into the one that's factored. All right. So if I plug the -3, say I've got to plug the -3 in for x, into the x here, and then the x for this one. So if I plug -3 in for x, that's going to be -3, which is a negative. Plug the -3 into here, that's going to be -3 minus 2 is -5, which is negative. And -3 plus 2 is -1, which is negative. So a negative times a negative, that would be a positive. And then a positive times a negative is negative. So these would be negative solutions. And then I've got x equal -1. So if I plug the -1 into here, that's going to be a negative. Plug the -1 into here, -1 minus 2 is -3, which is a negative number. And -1 plus 2 is +1, which is a positive number. A negative times a negative is positive, and then a positive times a positive is positive. So these are all positive. And then I've got x equal 1. We're going to do this one. So plug the 1 in, that's positive. Plug the 1 in, 1 minus 2, that's a negative number. And then 1 plus 2 is a positive number. So a positive times a negative is negative, and then a negative times a positive is negative. So this would be negative. And then we've got x equal 3. So plug the 3 in, that's going to be positive. 3 minus 2 is 1, that's positive. 3 plus 2 is 5, that's positive. Positive times a positive is positive. Positive times a positive is positive. So all of these are positive. All right. So what do we want to know? We want to know, when is this inequality? When is this inequality here? When is it positive? Well, it's positive here, and it's positive here. And so that's going to be -2 to 0. We're using parentheses because it's not greater than or equal to, it's just greater than, or 2 to infinity. And there's your answer. So you can see it's not bad. And that's how you solve these polynomial inequalities. So the main thing right now is, do you understand the process that I'm doing over here? That's the main thing, is understanding what I did there. Because if you understand that, then this right here, this over here, is exactly what we're going to do with the rational inequalities. The only thing that's going to be a little different with the rational inequalities is what I do over here. Okay? All right, so let's go over here. All right, steps for solving inequalities involving rational expressions. Rewrite the inequalities so that all the terms are on the left side and the 0 is on the right side. So get everything to the left side and just 0 by itself. Write the left side as a single fraction. This right here, this step right here, is probably the one that students struggle with the most. Might be the most difficult part of them. Set the numerator and denominator equal to 0 and solve for x. So we're going to set the numerator equal to 0, set the denominator equal to 0, and solve. Divide the x-axis into regions using solutions found in steps 3. So basically what we have here is 4 through 5 is this part of it right here. That's what that is. It's the same as the polynomials. Test a point in each region by choosing a value for x and substituting it into the equation for y, and then determine which regions satisfy the original inequality and graph the solution. All right, so let's solve. So it's telling us get everything to one side of the inequality symbol and 0 by itself. Well, this is already like that, so we're good. So now what we do is we take the numerator, set it equal to 0, and set the denominator equal to 0. And so we've got x equal 4 or x equal 1. And now it's just like what we did before. We set up a number line. And so we're going to have, let's see, how about x equals 0, x equal 2, and x equal 5. All right. Now, this one's easy. So what we got to do, we're going to take this and we're going to plug it into the single fraction over here. Okay. So for x equal 0, so once again, you don't have to get the exact answer. You've just got to know, is it positive or negative? So we're going to do the same thing. So if I plug 0 into the numerator, 0 minus 4 is negative 4, which is a negative number, divided by, and then we plug 0 in for x in the denominator. 0 minus 1 is negative 1, which that's a negative. A negative over a negative is positive, and so this is positive. And then we do the x equal 2. So 2 minus 4 is negative 2, so that would be negative. 2 minus 1 is positive 1, that's positive. A negative over a positive, a negative divided by a positive is negative, so this would be negative in here. And then we've got the x equal 5, and so x equal 5. So 5 minus 4, that's a positive number. 5 minus 1 is a positive number. And so a positive over a positive is positive. Okay, so same thing we did up there with polynomials. All right, now, what do we want to know? We want to know, when is this inequality here, when is it greater than or equal to 0? When is it positive or equal to 0? Well, you can see it's positive here and here. Okay, so what's our solution? It's negative infinity to 1 or 4 to infinity. Now, it's greater than or equal to, so that means we include the numbers, our solutions there. So we're going to have this is our answer. All right. Now, I know what you're thinking. I already know. But it's included. How come you don't have a bracket over here? Because it's or equal to. You got a bracket on the 4, but you don't have a bracket on the 1. That's right. It's included because it's or equal to. Greater than or equal to. That's going to make us have the bracket right here. But why did I put a parenthesis on the 1? Well, let's do this. If we plug the 4 in, 4 minus 4 is 0. 4 minus 1 is 3, which is equal to 0. That satisfies 0 greater than or equal to 0. That satisfies that inequality. Well, let's plug the 1 in. 1 minus 4 over 1 minus 1 is negative 3 over 0. Oh, what happened there? That gave us a 0 in the denominator. And remember, this is undefined. So although it says or equal to, when you're doing the rational inequalities, you've got to be careful and make sure that if it is or equal to, that like this 1 here, that would make the denominator 0, so that means we can include it. Okay? All right. Let's go to the next one. All right. So here we've got 5 over x plus 4 is greater than or equal to 1. All right, so here's the one where students struggle. So let's go through this step by step. Let's show all the work. All right, so we're going to subtract 1 to both sides. So I got 5 over x plus 4 minus 1 is greater than or equal to 0. And so what I need to do here is I need to get a common denominator. Okay, we can look at that as being 1 over 1. All right, so remember how to do this. All right, you learned this in college algebra or algebra whenever you took that. All right, so I look at this denominator. What do I multiply to this denominator to get my common denominator? So I multiply by 1. So 1 times 5 is 5. And then what do I multiply to this denominator here, this 1 here in the denominator? What do I multiply to that to get my common denominator? I multiply x plus 4. So x plus 4 times this 1 is x plus 4. And so now I get 5 minus x plus 4. Make sure you put that in parentheses because it's minus. And that's going to be over x plus 4 is greater than or equal to 0. So 5 minus x minus 4 over x plus 4 is greater than or equal to 0. So that's going to give me 1 minus x over x plus 4 is greater than or equal to 0. All right. All right, so what did it say to do then? It said to take the numerator, 1 minus x, set it equal to 0, and set the denominator equal to 0. So here, if I move the x over, I get x equal 1 and x equal negative 4. And so I'll plot the negative 4 and the 1, breaks it up into three regions. So I'm going to choose x equal negative 5, x equal, how about we do 0, and x equal 2. All right. So now I've got to test out x equal negative 5. All right. Now, where are we going to plug this in? Well, we can plug it into any one of them, but look, plug it into the one where you have it written as a single fraction and then 0 on the other side. A single fraction on one side of the inequality and 0 on the other. Write it like that. All right, so let's plug the negative 5 in. So I've got 1 minus negative 5. So write that 1 minus negative 5. That's the same thing as 1 plus 5, which that's going to be a positive. Over, and then if I plug negative 5 into here, negative 5 plus 4 is negative 1. That's a negative. And so a positive over a negative is negative. So this is negative right here. And then we have x equal 0. So if I plug the 0 in, 1 minus 0 is 1. That's positive. Over, and then 0 plus 4 is positive. It's positive 4, so that's positive. So that is a positive. So everything in this region is positive. And then x equal 2. Well, plug the 2 in. 1 minus 2 is negative 1. That's negative. And 2 plus 4, that's positive. And a negative over a positive is negative, so this is negative. And what do we want to know? We want to know, when is this thing right here, when is it greater than or equal to 0? So when is it positive or equal to 0? And that's right here. And so our solution is between negative 4 and 1. Now, remember, this is where you have to be careful. It is or equal to. So we're going to have a bracket on the 1 and a parenthesis on the negative 4. We cannot include the negative 4 because that makes it 0 in the denominator. Okay? All right. And you know, stay tuned for towards the end of the video after I work this last problem, because I want to show you something that you might think to do, but you can't. All right, so here we go. We got another one. This is the last one. So subtract 5. So I've got 2x minus 1 over 3x plus 4 minus 5 is less than 0. And we can look at this as being over 1. Okay? So I need to get a common denominator, which is 3x plus 4. All right, so this is going to be 2x minus 1, because what do you multiply this denominator to get this denominator? You multiply by 1. So what do I multiply to this denominator to get this one? Well, I have to multiply this by 3x plus 4. So I've got 5 times 3x plus 4. And so this is going to give me 2x minus 1 minus 5 times 3x plus 4 over 3x plus 4 is less than 0. So now I've got 2x minus 1 minus 15x minus 20 over 3x plus 4 is less than 0. And so this is going to give me 2x. 2x minus 15x is negative 13x. Minus 1 minus 20 is minus 21 over 3x plus 4 less than 0. So I set the numerator equal to 0. Negative 13x minus 21 equals 0. And 3x plus 4 equals 0. So that's negative 13x equals 21. X equals negative 21 over 13. And here we get 3x equal negative 4. X is equal to negative 4/3. Okay. All right, so we need to plot these on the number line. Okay, so for this one, you sit there and you think about, okay, where does this go? Which number goes where? Okay, you may not know which number is larger than the other. So what you can do is you can actually take your calculator and do just punch in negative 21 divided by 13 and negative 4 divided by 3 and kind of write down a few decimal places. All right, so we've got negative 21 divided by 13. That is equal to negative 1.62. We'll round it. And then we got negative 4 divided by 3. That is equal to negative 1.33. So we would have negative 1.62 and negative 1.33. And this is going to break it up into 3 regions. So here we can choose x equal negative 2, x equal, we can do negative 1, and then here we can do, well, we can actually do x equal what? Negative 1.5, okay? So you can see this one's a little bit, it's a little tougher. But let's think about this, okay? So this is where it comes in handy, not worrying about getting the exact answer. So if we plug negative 2 in, negative 13 times negative 2 is positive 26. 26 minus 21 is a positive number. And then if we plug the negative 2 into here, we've got 3 times negative 2 is negative 6. Negative 6 plus 4 is a negative number. And so that's negative. So this is going to be negative here. Now let's look at the negative 1.5. X equal negative 1.5. So this one I might need to punch into my calculator. Negative 13 times negative 1.5 minus 21. That's negative 1.5, so that's a negative up here. And then 3 times negative 1.5 plus 4 is negative 0.5. So that's a negative down here. So that's going to be a positive. And then we've got x equal negative 1. So think about this. Negative 13 times negative 1 is positive 13. 13 minus 21 is negative. 3 times negative 1 is negative 3. Negative 3 plus 4 is positive 1. That's positive. And so a negative over a positive is negative. So that's negative. And what do we want to know? We want to know when is this thing, when is it less than 0? So that's negative, less than 0, same thing as negative. That's here and here. So we can see that our solution is negative infinity to negative 21 over 13, or negative 4/3 to positive infinity. I just used, all I did, I used these numbers here. I used the fractions. It looks nicer. You know, if you want, I guess you could put the fractions. That would be the same thing if you use the fractions. All right. So now what I wanted to say, that's how you do this. I mean, it's not difficult. Like I said, the thing that students struggle with the most is this part right here. Okay. All right. So let's bring this up. So I've got 5 over x plus 4 greater than or equal to 1. And what did I do here? I took the 1 and I brought it over. Okay, I brought it over and got a single fraction. So I know what you might be thinking. You might be thinking, well, instead of doing that, why don't we just multiply both sides by x plus 4 and it gets rid of the fraction for me? You can't do that, okay? You can get incorrect answers by doing that. And then the next thing I need to ask you is, if you remember when you're solving inequalities, remember if you multiply or divide both sides by a negative number, you have to reverse the inequality symbol. So let me ask you this. When I multiply both sides by x plus 4, do I need to reverse the symbol? Is x plus 4 positive or is it negative? Well, you don't know. It depends on what x is. So you cannot do this. This is no, no, no. Okay? You have to move the number over and get a single fraction. Okay? So that's all of this video. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.